Hi class, it's Mrs. Kane and I'm back for another lesson. It's about 8:30 in the morning and my kids, who are usually up between 7:30 and 8, are still sleeping. So I'm going to try and get this recording done before they wake up, so hopefully it won't be interrupted. Alright, so yesterday we talked about properties of logarithms, and we specifically talked about expanding logs, so using the properties to expand. So I want to start by just kind of reviewing those properties and practicing a couple expanding problems. So we talked about the product, quotient, and power property yesterday, and I wrote those out for you. They're kind of color-coded. Okay, and when we expand, we're trying to take a single log and write it as either a sum, a difference, or if we have an exponent, we bring that exponent out in front. And so when we change it from a single log into an addition, subtraction, or bring that exponent out in front, we call that an expansion. So when we do this, we are expanding our logarithm. Okay, and that was the focus of yesterday's notes, was understanding the properties and then using them to expand. So let's go ahead and just practice what I talked about in yesterday's video. So this first problem, we have log base 2 of 9x cubed y. Okay, so the first thing I want you to notice is that you have three terms. You have a 9, an x cubed, and a y. And so when we expand this, we're going to write log base 2 3 times. Each term is going to get its own log. So log base 2 of 9. Now when we pull apart multiplication, we use addition. So plus log base 2 of x cubed plus log base 2 of y. Okay, so each of the three terms get their own log with the base of 2. And then the last step, if you have any exponents, you're going to put those in front of the log. And so we're going to write log base 2 of 9 plus 3 log base 2 of x plus log base 2 of y. Okay, and don't drop that log base 2. It's important that you keep that base of 2 in your answer. Okay, in the next example, we're going to review what do we do with this cubed root here. So we have log base 5 of 3 times the cubed root of a. So we don't have a property for roots, but we do have a property for exponents. And so we're going to start by rewriting this as log base 5 of 3a to the 1/3 power. So the cubed root of a can be written as a to the 1/3 power. Okay, so now we have two terms. We have an 3 and we have an a to the 1/3. So we're going to pull those apart, again using addition. Okay, and then we can take this 1/3 and we can bring it in front of the log. So we get log base 5 of 3 plus 1/3 times log base 5 of a. Okay. And then the last warm-up problem here, we have three terms. We have a 6, an x squared, and a y to the 4th. And notice that the 6 is being divided by a product, x squared and y to the 4th. So we're going to start this one. We have three terms, so log base 7 of 6. Now I'm going to subtract a product, and when we pull apart a product, we use addition. So notice that I'm going to put log base 7 of x squared plus log base 7 of y to the 4th in parentheses. Okay, now this 2 is going to come out in front, and this 4 is going to come out in front. Okay, and I'm also going to distribute my minus sign. So I have log base 7 of 6 minus, I'm going to write 2 log base 7 of x, and then I'm going to subtract 4 log base 7 of y. Okay, so I put those exponents out in front, and then in addition, I distributed that minus sign. Okay, and notice that the x squared and the y to the 4th are both on the bottom of the fraction, and so they both have a minus sign in front of the expressions. So I've got my minus here, and I've got a minus here because both of those terms are on the bottom. All right, so now we're going to focus on condensing logs. So we're going to work backwards. Okay, so we're still working with the same properties, okay, but we're going to use them in the reverse order. So if we see an addition of logs and we want to write that as a single log, what we're going to do is we're going to condense them. We're only going to write one single log. So if we have log base b of a plus log base b of c, okay, we can kind of smush those together using multiplication. Okay, so same properties as above, but now we're going to go in the reverse order. So instead of expanding them, we're going to put them back together. Okay, so addition becomes multiplication. Similarly, if we have a quotient, we're going to go ahead and put those back together in a single log using division. And then lastly, if we want to condense using the power property, if we notice a constant in front of a log that is being multiplied, we're going to put that constant up here and make it an exponent. So log base b of a to the c. Okay, so if we understood how to expand, then now we're going to go in the reverse order and we're going to condense. All right, so same properties, just a different order. So let's see how this goes. Let's try a couple together. All right, so we have log of 10 plus log of 4 minus log of 5. So when we condense the first two, we're going to do log of 10 times 4 is 40. And then we have to subtract log of 5. So I'm going to do this in 2 steps. So first I'm going to combine the first two to get log of 40. And then I'm going to tack on minus log 5. And so subtraction becomes a division. And so we end up with log of 8. Okay, and notice there's no log written, or I'm sorry, there's no base written, so that means the base is 10. Okay, so the next one. The first thing I notice, I always want to get rid of these numbers out in front first. So this 1/2 is a constant that's being multiplied by log a. So I'm going to start by making that an exponent. So we've got log 6 plus log of a to the 1/2. Okay, and now addition becomes multiplication, and so we get log of 6a to the 1/2. And you can also write that as log of 6 times the square root of a. Okay, so if we want to condense it and make it as tight as possible, log of 6 square root of a. All right, so always look for those numbers out in front first. You want to use the power property first before you combine. So if we look at part C, I've got a 2 out in front. That's going to become an exponent on the 7. And then I've got a 4 out in front. That's going to become an exponent for the x. And so I'm going to start by writing log base 3 of 7 squared minus log base 3 of x to the 4th. Okay, and then the subtraction tells me to divide. So my goal here is to just write one single log. So 7 squared is 49. And then I'm going to divide that by my second term, which is x to the 4th. Okay. Now, condensing logs can be very useful because it oftentimes allows us to simplify a log that otherwise cannot be simplified. So in the next set of problems, we're going to use properties to condense our logs, and then we're going to evaluate using our conversion into exponential form. So in the next set of problems, first we're going to write them as single logs, then we're going to evaluate. And you're going to notice these are all numerical logs. We don't have any variables. All right, so the first problem, we have log base 6 of 4 plus log base 6 of 9. So we're going to start by writing a single log, log base 6. We're going to multiply 4 times 9 to get 36. And notice now we can go ahead and evaluate that. 6 to what power equals 36? Okay, so we know 6 squared is 36, and so the answer is 2. Okay, so individually we were not able to evaluate those, but once we condensed them, then it was an easy problem to evaluate. All right, let's try another one. So this one, we have log base 5 of 35 minus log base 5 of 7. So when we condense those, we get log base 5, 35 divided by 7 is 5. Okay, and so now we can do 5 to what power equals 5? We know 5 to the first power is 5, and so the answer is 1. Okay. All right, the last couple problems here. Notice we have these, we have a couple numbers in front. So we always want to move these exponents, or these numbers out in front, make them exponents first. Okay, so I'm going to start this problem by writing log base 3 of 6 squared, which is 36, minus log base 3 of 4. Okay, now I'm going to condense. So I have log base 3. 36 divided by 4 is 9. Okay, and now it's a simple log to evaluate. 3 to what power equals 9. Okay, we know 3 squared is 9, and so the answer equals 2. Okay, so kind of a useful, a very useful result of condensing. All right, and then this last one, we have 1/2 out in front. That's going to become an exponent. So we have log base 3 of 9 to the 1/2. Remember, that's the square root of 9, which is 3, minus log base 3 of 27. Okay, so subtraction means we're going to divide. So now if I condense, I get log base 3 of 3 over 27. Okay, so that's going to be log base 3 of 1/9. And so we have to figure out 3 to what power equals 1/9. So we know 3 squared is 9. So if it's 1/9, then that exponent must be negative. And so the answer is -2. Okay, so I'd like you to go ahead and pause the video, try the last 2 problems, and then just fast forward to the end to check your answers. And I'm going to kind of zip through these. So we have log base 2. This one would be 24 divided by 3. 24 divided by 3 is 8. And then once we condense, we can go ahead and simplify or evaluate. So 2 to what power is 8? 2 to the 3rd. And so the answer is 3. Okay, and then this last one, we've got log base 4 of, we have to divide 3 over 48. So that's going to be log base 4 of 1 over 16. Okay, and so then we're going to say 4 to what power is 1 over 16? And so that's going to be -2. So the answer is -2. All right, so condensing and evaluating. I hope that made sense. And we will continue talking about this. We'll review the properties in tomorrow's lesson.